Yes, welcome back. We'll do the next problem. Yes, another one from control systems using RH. Okay, so the second or the third unit, the stability and time domain, both RH root closely, and even in frequency domain, you got good number of problems from control systems. Yes, this one using RH criteria, Raoult's criteria. Last one is Nyquist stability. This is based on Raoult's stability. Yes, what is given? Probably the statement given as a polynomial or equation of a system. Okay, so for which you need to find the roots. Okay, for actually for which the roots are given, and for that you need to find the range of k. Okay, let me get into the statement. Okay, this is how it is given, but anyway the structure of the problem remains same. The statements, okay, the words used may be little different. Okay, so let me take it as a the characteristic equation of a system is given by s power 4 plus 5s square plus 4 plus k is equal to 0, where k is a positive real parameter we can, where k is a real parameter we can take. So the complete range of k, even if it is not mentioned, the complete range of k means your k will take values from k can take value from minus infinity to plus infinity. It's an open boundary. Okay. The complete range of k for which all its roots are on the imaginary axis is. It was a MCQ problem. Okay. So ranges are given for the k. I didn't remember exactly the ranges given, so but still we'll go for, okay, the accurate answer I know, but still we'll find it, okay, where it is going to be. Okay, so by Raut-Hurwitz you can take the coefficients of your characteristic equation. Okay, so using that principle, yes, the first row will begin with s power 4, the highest power of your characteristic equation, s power 2, then s power 3, actually s power 2, and then s power 1, s power 0. At any cost, we have to go down till s power 0 as per Raoult's array principle. So we are going to form the Raoult's array. From this, we are going to conclude Raoult's stability, and from this, we are going to force the condition given. What is that? The complete range of k for which all its roots on the imaginary axis. That means what? Your k value has to make, that means range of k has to make your system completely marginally stable. That's what indirectly is pointing. Okay. So you might have asked instead of this, he's very direct. He's straight away giving keep the poles on the keep the roots on the imaginary axis. All the roots, how many roots? 4 roots. All the 4 roots should be on the imaginary axis. That is the straightforward statement. You should have given, okay, so the range of k for which the given system is, the complete range of k for which the given system is marginally stable means that is little indirect. So he helped you, designer helped you by saying all the roots are on the imaginary axis. Okay, so let us find that boundary of k. Yes, let us get into the problem. So first equation is going to become, so s power 4 coefficient, it's 1. So remember, we have only even powers. Okay, so s power 4 is there, s square is there, s power 0 is there. That means the first row is filled by the coefficients of the given characteristic equation. So it's 1, 5, and 4 plus k. That's all. But what about the next row? Doesn't have any coefficients. So one row completely vanishes. And you have the basics. If one row completely vanishes, it says the given system is marginally stable. That means the roots are symmetric, and the symmetric roots either will be falling on real axis or on imaginary axis. But you can't directly go for all the roots now, okay, because it is a fourth order equation. Fine, then what to do now? What is the next step? So take this as a polynomial q of s that is equal to s power 4 plus 5s square plus 4 plus k. Differentiate it. So dq by ds is equal to, so it's going to be 4 s cube plus 10s. That's all. That's your auxiliary equation. So replace this by the new coefficients. That's how we need to proceed. So this is going to become 4, and this is going to become, this is going to be 10, and this is 0. Yes, now as per the logic, is 4 into 5 minus 10, then 4 into this minus this, then you know the logic connected. Okay, so what is this number then? It's going to be 20 minus 10 by 4. It is going to be 20 minus 10 by 4. Let me take that way. No problem. 20 minus 10 by 4. Correct. Then what do you get? 4 into 4 plus k. 4 into 4 plus k by 4 only you will get. 4 into 4 plus k minus 0 you will get divided by 4. So that means you're going to get 4 plus k here straight away. So this will be 4 plus k. And this will be 0. Yes. Now let me simplify this. 20 minus 10 is 10. So 10 by 4 is going to be 2.5. Let me take 2.5. Okay. Yes. Now. So 2.5 into 10, same logic. 2.5 into 10 is 25 minus 4 into 4 plus k. 4 into 4 plus k divided by 2.5 will get. Okay. Then next will be 2.5 into 0 minus 4 into 0 divided by this. So it is going to become 0. Okay. So this is also going to become 0. And call this as a x, and x into 4 plus k, x into 4 plus k minus this divided by x. Okay. Will be 4 plus k. That's all. So you got the first column. Now ready for the conclusion. So these are the first column elements of routes array. Referring the first column elements, there should not be any sign change if you want the system to be stable. If there are sign changes, number of sign changes represents number of routes on right hand side. But anyway, the intention is not to place routes on both left side as well as right side. We have to keep the route strictly on imaginary axis. That means we need to make the entire row 0 again. So that means this row can be made 0 again. So this row can be made 0 again. How to make this row 0? And this row also can be made 0. That means, yes, it has to be, and k, yes, this is giving a straightforward point. Okay, k should not be, k should be such that the poles should be neither on the left side or on the right side. So that means 4 plus k. Okay, so k greater than minus 4. Okay, k greater than minus 4, there is no sign change. This is plus, this is plus, this is plus, this is also going to be plus. So k equal to minus 4 is the one boundary. K equal to minus 4 is one boundary. We have to check it because here we have s power 0th row. Okay, so then this row 0 means definitely this is going to say the system is again marginally stable. So therefore, you need to force this to 0. So there is nothing but 25 minus of 4 into 4 plus k. So that means expand it. If we expand it, 25 minus 4 into 4, that is 16. 4 into k, so plus 4k equal to 0 will be marginally stable condition. Yes, force it. 25 minus 6 will become 9. So it's going to be 9 minus 4k is equal to 0 for the marginally stable condition. So therefore 4k must be equal to 9 and k must be equal to 9 by 4. So k equal to 9 by 4 is marginally stable condition. So entire row will vanish. Okay, k equal to 9 by 4, k equal to minus 4, we have to check. So let me check it. So we have two conditions. So k between, this is one of the options, minus 4 and 9 by 4. Okay, k between this. What is our equation? S square, s power 4, s power 4 plus 4s square plus 4 plus k. That is equal to 0. Now in this force k equal to minus 4, you got roughly the range. You are going for the confirmation. So let me force k is equal to minus 4. K equal to minus 4 means this will vanish. You'll end up with s power 4 plus 4s square equal to 0. That means that s square into s square plus 4 is equal to 0. Hope I'm right. Then s square equal to 0 and s square plus 4 is equal to 0. We'll have s square equal to minus 4. S is equal to plus or minus j2. That means you have the poles here. 2 poles at origin and 1 pole at plus j2, another pole at minus j2. Condition is obeyed. All the poles are on the j omega axis when k is equal to minus 4. That's fine. Then 9 by 4. When k is equal to 9 by 4, we'll see what happens. K equal to 9 by 4 means it is s power 4 plus 4s square plus k equal to 9 by 4 means it's 4 plus 9 by 4. What do you get then? Equal to 0 means then you will end up with, so 4 plus 4 is going to be 16, 16 plus 9, 25, 25 by 4 you will get. So s power 4 plus 4s square plus 25 by 4 you will get, okay, is equal to 0. K equal to 9 by 4. So 16 plus 9, 25, it's correct. So then you may write it as only you have to check this. Okay. So I can write it as x square plus 4x plus 25 by 4. Then you need to confirm that the roots are on j omega axis. So then x will be equal to minus 4 plus or minus root of b square. That is 16 minus 4ac. 16 minus 4ac means it's going to be 25 divided by 2a. So then as a result, okay. That's verification. We are almost concluding this. X is equal to minus 4 plus or minus root of 16 minus 25 will be 16 minus 25 will be 9. So it's going to be minus can be taken out with a j. So 9 will be there. So it will be 3 divided by 2 you will get. So that's going to be minus 2 plus or minus j 1.5. Okay, that is only your x. That is nothing but what? A square. Okay, yes. A square is equal to this because x is equal to yes. Okay, fine then. So that is minus 2 plus or minus. Okay, 1 minute. Confirmation is mandatory. So minus 2 plus j means that is not giving a perception like all are on the imaginary axis. Then how to perceive? K is equal to yes. Anyway, this condition itself is sufficient to prove that. Okay, but in this case, only 2 will be on the imaginary. Okay, so under this condition, you will get that's auxiliary equation. You will prove these two only on the imaginary axis. Then remaining two also we need to prove. So that is little complex. When k is equal to 9 by 4, during the exam you can conclude like this. But when you are trying to prove it, yes. Minus 4 plus or minus root 16 minus 4ac, that's fine, divided by 2. Correct only. Another way is this. So when k is equal to minus k is equal to 9 by 4, what is the equation? Let me take a slide. So k is equal to 9 by 4. Then take the auxiliary polynomial from the RH. This is the auxiliary polynomial. That is 2.5 into a square plus, what is that? 4 plus k. So then that will give two roots. We'll go for the remaining roots. 4 plus k. That is equal to 0. That's your auxiliary equation. Then substitute k equal to 9 by 4. You'll get 2.5 into a square. So better you'll keep it as 5 by 2. 5 by 2 a square plus 4 plus k is 9 by 4. Then equal to 0 means it is going to be 5 by 2 into s square plus what I get again 25 by 4 I will get, that is equal to 0. Then multiply by 2 by 5. Okay, if you multiply by 2 by 5, this is going to become a square, and then it is 2 by 5 into 25 by 4 equal to 0. As a result, a square plus, so this is going to become 2, this is going to become 5 by 2 a square plus 2.5 equal to 0. So this is one root. That means what you need to do is you have s power 4 plus 5a square plus 4 plus 9 by 4, that is 25 by 4, I can say 25 by 4. In this is a factor. So s square plus 2.5, so s square plus 2.5 means 5 by 2 we can say. So shall I say it is s square plus 5 by 2 the whole square? Is it okay? So then I'll get s square plus, so 2ab, so 2 into 5 by 2 into s square plus 5 by 2 the whole square equal to 0 means I'll end up with s square plus, sorry, s power 4 it is. Okay, s power 4, 5s square plus 25 by 4 equal to 0. Yes. So that means yes, you got it. Where the poles are, yes. You should not leave during the practice. Okay, you have to go ahead, confirm, but in the examination, this will take time. You have to take a call with the characteristic equation itself, and then this is the right range. Okay. So if you try to verify, it takes time. So usually you give the answer which is very closer and make it mark and review usually in the examination. Then finally you can verify if you have the time, but it's MCQ. We should not land in negative marking. So that's why a quick verification is not easy. Maybe you may have some other methods. Okay, so to verify this is the way. Okay, k equal to -4 instantly verified, but k equal to 9 by 4 is getting little more time. So if you are strong in analytical stuff, you can quickly make it. Okay, faster than me. Okay, I hope so. So that's a interesting one. Okay, exploiting RH criteria. Okay, especially a very unique problem which never happened in the gate so far, because he's willing to have all the 4 roots on the j omega axis. Very interesting one. Okay, yes. So thanks for watching. We'll update you with one more problem soon. Do subscribe our channel and share to your friends as well.